We've had a great question related to earthquake early warning systems in relation to the Alpine Fault from Don. So he asks, given that the quake will take a couple of minutes to travel the length of the South Island, is it possible to have a rapid warning system through the civil defence text alerts the moment the quake starts that will give us a minute or so, or even longer for those in Wellington, to move into a safe place to drop cover and hold? I'd have thought there could be some sort of automated connection between the seismic sensors and the text alert system, or is that an impossible dream? Caroline, another chance to talk about
more sensors.
Sensors, yeah. So you've been involved in research exploring earthquake early warning systems. Can you tell us something about the possibility of such system here?
Yeah, so it's not a dream, it's actually already happening overseas. They have operational systems that give people or industry seconds of warning before incoming shaking after an earthquake. So it's not about predicting the earthquake, but it's about predicting incoming ground shaking. So like Japan, Mexico City, California, and Taiwan. So yeah, in New Zealand, there's definitely an appetite, as demonstrated by colleagues from Massey University, an appetite for early warning system in New Zealand. And we're very lucky that we can benefit from learning from the successes, but also the failure of those systems overseas. Now, I have to remind everyone that I'm a seismologist, so I'd love it to be just about seismology, but actually an earthquake early warning is about the end users who needs it, and they will define what's the success of that system. And they're really important because they will define the threshold they're interested in, whether they're interested in strong shaking, warning for strong shaking, or warning for, felt level of shaking, or even warning for like shutting down critical infrastructures. So depending on the needs, the system will be quite different. These guys also are really important because we need to have a pretty strong engagement with the end users so that they're aware of the uncertainties around the system, but also the limitations of such systems. And finally, because they will be the one funding it. So we really need, to be like quite transparent and to be aligned with the end users about what we can provide for at what cost. Now, just as an example, so in New Zealand it's happening. We're currently testing 2 different types of early warning systems for two different end users. The first one is our national level. So we're looking at end users such as NEMA, here represented by Tom, or EQC, or Fire New Zealand. So these would be the national stakeholders that are really interested in a national level earthquake early warning system. And it would be based on a GeoNet monitoring network. Yeah, I'll just stop here. And the other one was actually, it's a community-based earthquake early warning system, where now the end users is you and I, the people of New Zealand, and so we would be empowering people by hosting a census, and then they would be providing support for the alerts. So this is another research project that is happening with Massey University. So yeah, so it's a really bubbling topic. It's we're currently testing it, and it's all about cost-benefit analysis as well. So I can go and see Tom and say, hey, this is how much it might cost, but actually the benefit would be such and such. So yeah, so it's a really exciting field to be in because we have the infrastructures in New Zealand, we have the expertise, we have the appetite. We just need now to discuss, what kind of system should we be implementing. So yeah, hopefully I can be invited next year again to this conversation and show you like a lot more progress as well.